Okay, so we're tracking the location of the bug as it travels around the fan, and we're seeing this, kind of looking at this through the lens of some functions we can develop that will output this location of the bug. So the first function, the input is the angle, and we said we need to be really specific about what angle we're talking about. And so this is the angle swept counterclockwise from the 3 o'clock position. And that will be in radians. Okay, the angle swept counterclockwise from the 3 o'clock position in radians. And so where we left off last time, we were looking at vertical distance. So as the fan turns, we can track the vertical distance above the horizontal diameter. So that's going to be the output of this function that we're creating. And that was in feet. So the number of feet that the bug is above the horizontal diameter as the angle. So that changes, obviously, as the angle changes. So we had started to kind of explore the covariation of these two quantities, and this was our means of doing that, right? We ask for equal changes in the input, which in this case is the angle. We're asking, first of all, what does the output do? So let's look at this this first quadrant of rotation. When the angle is 0, right here at the 3 o'clock position, no openness, right? It's totally closed. What is the vertical distance above the horizontal diameter? So what's the corresponding vertical distance for an input of 0 radians? 0, right? It's on the horizontal diameter, so there's no distance above or below. So we're going to start with this point, 0, 0. Okay? As this angle increases from 0 to pi over 2, what does the vertical distance do? How does it change? Does it increase or decrease? Obviously it increases. The bug goes up, right? The bug goes up from 0 to what? So what is... From 0, the vertical distance increases from 0 to what? There's only one radius. So what value does it increase to? 2.6. So we'll label over here. So let's make this right here. This is pi over 2. That's the current angle, right, that I'm showing. At pi over 2, the vertical distance of the bug above the horizontal diameter is 2.6. So we know that it's going to increase from 0 to 2.6 as the angle increases from 0 to pi over 2. The question is, how does it do that? So that's when we get to questions 2 and 3, and we're looking at the changes. So what do the changes do in that first quadrant? Are those positive or negative changes, first of all? Positive, because the vertical distance is increasing. If our quantity is increasing, we have positive changes, and so those getting more or less positive. So you can look over there and you can, sorry. So you can see the changes right here. So here's the first change for the first angle. And then for the next equal amount of angle swept out, here's the next change, and then the next change, and the next change. So those changes are getting, there's changes that are getting smaller, they're getting less positive. So are the changes increasing or decreasing? The changes are decreasing. So what about the rate of change? Yeah, so the rate just follows right along with the changes. So the reason we analyze the changes is because that then gives us what the rate is doing. So the changes are becoming less negative or decreasing. So our rate of change there is decreasing. And how does that show up in the graph? A decreasing rate of change. Concave down. Concave down. Next quadrant. The vertical distance starts at 2.6, and does it increase or decrease? Decreases to what? 0. It's at 2.6 here. That vertical distance decreases to 0. So we know that, and what angle is that right now that I'm showing? Pi. The openness of pi radians, okay? Which comes from about 3.14 radius lengths covering half of a circle. Okay, so it's going to return this vertical distance, the output returns back to 0. Yeah, so our input is on the horizontal axis here, and this is our angle, which we've defined very specifically up here. And then our vertical axis is the output, or the vertical distance above, okay? So you got to imagine, as that angle sweeps open, it's like we're moving horizontally across this axis. That's that angle. And then the vertical axis on this graph that we're developing is the vertical height of the bug as the angle changes. So you told me that when it reaches pi, it's back down to 0. So now those changes in that quadrant, second quadrant, are those changes positive or negative changes? Negative. Our quantity is decreasing, so we got negative changes. Becoming more or less negative? Good, more negative. Okay, so those are becoming more negative. You can see that here. The first change there, second change, third change. So are those decreasing or increasing changes? Decreasing changes. The amount of distance covered by the bug each time is increasing. But because those are negative changes, larger and larger negative changes means decreasing rate. And so what about the graph? Concave down. Okay. Third quadrant. First of all, does the vertical distance increase of the bug increase or decrease? The vertical distance decrease or increase? Sorry. I'm hearing both. Right now, through this third quadrant, is that vertical distance increasing or decreasing? Let's do the other question first. What is the value of the vertical distance here? 0. What's the value of the vertical distance here? Above. Negative 2.6. So was that an increase or decrease from 0 to negative 2.6? Decrease. Okay, so we're here at 0, and then the bug's vertical distance decreases to negative 2.6. So the changes, if that quantity is decreasing, those changes are positive or negative? Negative changes becoming more or less negative. Those are negative changes becoming less negative. Therefore, the changes are increasing. Those are increasing changes. Even though the distance is getting shorter, those are negative changes. So those changes are increasing, and therefore the rate of change is increasing, and the graph is concave up in that third quadrant. Fourth quadrant. the distance above horizontal diameter goes from what to what? So what does it start at? What's the output quantity? Negative 2.6. And then as it traverses that quadrant, it ends up at 0. So is the vertical distance increasing or decreasing? Increases from negative 2.6 to 0. So therefore the changes are positive or negative? Positive changes. If we've got an increasing quantity, those changes are positive. Getting more positive or less positive? More positive. Therefore the rate of change is increasing, and the graph is concave up. So again, you're imagining going along this x-axis here, you're imagining the angle sweeping around a full circle, right? So this is the openness of the angle, making one full rotation. And then as that angle changes, this graph is showing correspondingly how the vertical distance of the bug changes. So in the first half of the circle, should make sense. In the first half of the circle, it goes up to the top and then back down to its original height of 0. And then the second half of the circle, it goes down to the lowest point, negative 2.6, and then back to its starting value of 0 on the midline. And so that's what that graph is showing. Okay. So we said that. So we said that the highest vertical distance that the bug attains is 2.6. And the minimum, negative 2.6. Okay, yeah, question?
So the first half,
yeah.
The change is decreasing, and then the second half will be increasing.
That's right, because, so all through the first half of the circle, at first the changes become, what, less through there, they become less positive, right? And then more negative. So the changes are decreasing for that whole first half of the circle. And the second half of the circle, here changes are becoming less negative and more positive. So they're increasing that whole way in the second half. Yep. Other questions? Okay. So we said that, like a week ago, or a couple days ago, we said that every circle could be represented as the unit circle. So how is that possible? So if this, instead of being measured in feet, we said this was the unit circle, then what would be the maximum height attained on the unit circle? 1, right? And what would be the minimum height? Down here. Negative 1, right? Can we see this fan as having a radius of 1? Is it possible somehow to think about this fan as having a radius of 1? How can we make sense of that? So we're kind of changing it up now. Instead of looking at feet, what unit would we be looking at if we thought of this vertical distance of the bug now is 1? 1 what?
Radius.
1 radius, right? 1 radius. So we can consider this fan to have a radius of 1 if that 1 just means the radius. 1 radius, okay? So we can change this output up. Instead of looking at in feet, we can say in what we call radius lengths. And then, so on this graph, we'd get the exact same graph, right? So now the maximum height is 1 radius length, goes back down to 0, then negative 1 radius length. We'd have the exact same graph if the input was the angle and the output was the vertical distance from the horizontal diameter, but now it's just a different unit, radius lengths. Okay, so this right here, the covariation of those two quantities, because any circle can be thought of with a radius of 1, whether it's a fan or a coin or an orbit of a planet, no matter what circle you're thinking about can be thought of as a radius of 1. Okay? 1 stands for how many radius lengths. So because we can, this relationship then could represent all circles, it's very special. Okay, so looking at that combination of input and output, oh no. Oh, I hate you. What are you doing? You keep going. Stuck? Maybe there's a bug on my computer. What happened? Are we back? No. I don't know what that was. Okay. But it happened at the wrong time. Oh, is it this? Anyway. So this relationship of these two input and output quantities. The input, the angle swept, counterclockwise from the 3 o'clock position. And the output, the vertical distance, no longer measured in feet, now measured in radius length, so it can be any circle. Does anybody, some of you know what that is? What function is that? This is sine. This is what the sine is. It's the relationship of these two quantities right here. Why? Because this can output the vertical distance above the horizontal diameter for any circle, for motion around any circle. Okay? Because that 1 universally could mean the radius, whatever the radius is. Okay, so let's take a look at right here, this angle right here. So what input angle am I showing right there? What input angle am I showing? We haven't talked about degrees all day. What angle are we showing? Pi over 4, right? It would be half of the pi over 2 angle. Okay, so pi over 4. So I want you to get your calculators out and put in. We're gonna put pi over 4 into this function. Okay, so pi over 4 is the input into this function. So before you do it, you're going to hit menu and make sure you're in radians. It's the 3rd line down. So hit menu, go down to the 3rd line. Make sure your calculator's in radians. So you're going to put, we're evaluating f of pi over 4, which is, you're going to write punch sine. And then pi is second caret. Second caret, and you're going to do pi over 4. And that's going to give us a number. Oh, this is no good. Shoot. All right, what number are we going to get?
0.707.
0.707. You should make sure you can get that. Shoot, I'm going to start over here. So first of all, let's just do this. Okay, so there we are. And we said that we're looking at this very important function, sine theta. And you just put in sine of this angle, pi over 4. And you should have gotten 0.707. So what the heck does that number mean? So what does that number mean? And how do we make sense of what we're looking at in terms of the number 0.707? Talk to the person next to you. How does 0.707 Reflect. What we're looking at here. What does that number mean? Go. Okay, Faisal, you're up. So what is that number, 0.707? What's the meaning of that number? Okay, the vertical distance from the x-axis to the bug is what he said. Okay, agree with that? So why is it 0.707? 0.707 what?
Radians.
Radians is an amount of openness. Radians is openness of an angle.
Radians.
He said 0.707 radius length. Is that right? So this is 0.707 radius lengths. And why does that number, 0.707, make sense with what we're looking at here? So he's saying it's 0.707 radius lengths above the horizontal diameter. How does that make sense? I thought it was 2.6 feet to the top. So shouldn't it be a lot higher than 0.707 at this moment? Adam?
0.7 is 70.7% of that 2.6.
Okay, so he's calling this 70 as like a percent. He's saying this is about 70% of what? Of the radius. So yeah, so right here. Yeah, thinking about percent is a good way. It's about 0.71 of the radius, right? So the height of the bug is about 0.71 of the radius above the horizontal diameter. Okay, and this up at the top was one full radius length at the top. So what values does the sine take on in the first quadrant as the bug goes from 0 to pi over 2? What about all those values that the sine outputs? What could you say about all those? Positive. Okay, what else? Percent of 1 radian. Right, they're the fraction of 1 radian. They're going to be less than 1, and it's going to be the fraction of 1 radius length. That is the height above the horizontal diameter. So what would you estimate the sine to be right there? What would you estimate the sine to be right there? Pi over 2? Pi over 2 is the angle. So I'm asking about the sine. What do you estimate the sine to be? Jimmy, what would you say? What would you guess for this angle right here, which is 3 pi over 8? 0.95. Does that make sense? It's like 95% of the way up to the top of the circle for one full radius. So yeah, so that red bar there is showing about 0.95 radius lengths. Okay? What about down here at pi over 8? Estimate the sine. What would you estimate the sine to be? Daniel. No, estimate. Don't plug it in. So what would you estimate the sine to be here at pi over 8? What's that? 0.4. 0.4. It's about 0.4 of a radius length above. Okay, so back to pi over 4. The sine is 0.7. So then, how would you find how many feet? At pi over 4, how would you get the number of feet that the bug is above the horizontal diameter? Go, do it. So get the number of feet that the bug is above the horizontal diameter. So get that number of feet. Where's Justin Richardson? There you are. How would you get the number of feet?
So I just
So you took 2.6 times the 0.707?
Yeah.
And what'd you get? Or did anybody?
1.83.
1.83? Yeah, so what we want is 0.71 of a radius length, so it's going to be 0.71 of 2.6 feet. Or, what you said, 2.6 times 0.707 gives you 1.83 feet above, which leads us to our second function that we want. The second function we'll call g, and we want g to be the original function that we did, the input of angle swept counterclockwise and the output of vertical distance above the horizontal diameter, now back in feet. So now we want to write that equation. Do it. So what would this new function g of theta be? It has the same input of angle, but now it outputs the number of feet above the horizontal diameter that we are. So how would you get that? Diana, do you think you have it? What function now we could input the angle and it would give us the number of feet we are above and below? She wants sine of theta times 2.6. Is it right? Yeah, because you're going to take that. What's sine of theta? It's going to be that fraction of the radius length that you are, and then you're going to take that fraction of 2.6. So the sine can work for any circle, and it gives us this vertical distance in radius lengths. And then we want a specific circle, and we want to have it output the units of the radius. Then we know that sine is going to give us that fraction of our radius, and so then we just multiply by the length of the radius. In this case, 2.6 feet would give us that vertical distance now in feet, which we built that graph up here. Okay, does it make sense? This is huge. This is really important. Okay, understanding the sine function, understanding what sine is, you've all heard of it, and many of you have had it dealt with it in the past. But understanding what sine is comes back to this. So knowing what its input and output are. So memorize it, study it, review it, repeat it over and over again. This, if you know this, then you know what the sine is. If you don't know that, you're probably not sure what exactly what the sine is. Okay, it's knowing what the input of sine is and what it gives us, the output. That's what understanding sine is all about. Okay, any questions on that? All right, so let's shift to horizontal distance from the vertical diameter. This is harder. Why is this harder? Because there's this nice transfer here. With sine, we're looking at vertical distance, and that matches up perfectly with our vertical axis. Okay, but now looking at horizontal distance, what makes this harder? Because now what's happening is we're taking the horizontal distance over on the circle and we're plotting it vertically in our graph. Do you see that? We're gonna be looking at horizontal distances over here, and then taking those values of horizontal distance and plotting them on the vertical axis in our graph so that you don't have this nice thing lining up like for the vertical distance, okay? So I'm going to set this going, and you can work on these. Again, you're looking at the covariation of now horizontal distance to the right of the vertical diameter. Okay, and we'll just go right to radius lengths, okay? We'll just do it right in radius lengths. And I'll change this here. We need, say, 64. And I'll just set this thing in motion. And I'm giving you some aids there, some visual aids to help you track the horizontal distance to the right of the vertical diameter. And you're going to go one quadrant at a time, and you're going to ask these three questions again. What's happening to the output of horizontal distance? What about the changes in horizontal distance? And then what about the rate of change? And then see if you can sketch the graph. This is in your, where is this? Investigation 2, I think. This is on page 269. Okay, so that you can create this graph one quadrant at a time. The bottom of page 269. It's the same exercise that we're doing. Okay, go talk it out. Okay, don't just jump to the final conclusion. Go through each quadrant and ask the questions and answer the questions for each quadrant. First quadrant. What's the angle right here? We're at 0. Okay? So, so we're here at angle 0. What is the horizontal distance to the right of the vertical diameter when the angle is 0? Do you see this? It's 1 radius length. So therefore we graph it here. It's 1. You see? This is trickier. So at an angle of 0, our horizontal distance to the right is 1. So that starts at this point up here. And what happens at horizontal distance as the angle increases from 0 to pi over 2? What does that horizontal distance do? It goes from 1 to 0. At pi over 2, the horizontal distance is 0. And so at pi over 2, let's do it. Okay? And what about the changes? Do the changes become, in that quadrant, more or less positive or negative? Someone said more negative. Agree with that? Yeah. This is a decreasing quantity here. That horizontal distance to the right is decreasing, and so those changes are negative, and they're getting bigger negative. Here's the first, here's the second, here's the third. They're getting bigger negative. So is the rate of change increasing or decreasing? The rate of change. Decreasing. It's getting faster negative, right? And that's a decreasing rate of change, so it's concave down. Second quadrant. What does the horizontal distance, it's here, it's at 0. In the second quadrant, when we go to pi, what will the horizontal distance do? Go from 0 to what? 0 to negative 1. So at pi, the horizontal distance is down here at negative 1. So at an angle of pi, the horizontal distance is negative 1 now. What happened in those changes? Are those negative or positive changes? We're still decreasing, right? So the horizontal distance is decreasing, so those are negative changes, getting more or less negative? Less negative. Therefore, the changes are increasing or decreasing? Increasing changes. And therefore, the rate of change is increasing, and the graph is concave up. Next quadrant. The horizontal distance goes from -1 to what in the next quadrant? So what will the horizontal distance do as we go from pi to 1.5 pi? Goes back to 0. Is that increasing or decreasing? Our horizontal distance is increasing back from -1 to 0. And how does it do that? What about the changes? Are they increasing or positive or negative changes? Positive changes because the function is increasing. More positive or less positive? More positive. Therefore, increasing rate of change, concave up. Increasing rate of change, concave up. Last quadrant, the horizontal distance goes from what to what? 0. Here it's 0. The horizontal distance is 0. Now the horizontal distance is to 1. Positive or negative changes? Positive changes. Getting more or less positive through here? Getting less. Here are the changes. Boom, 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 boom. Getting less positive. Therefore, the rate of change is? Rate of change is decreasing, and the graph is concave down. Concave down. Okay, so here our input is angle swept counterclockwise from 3 o'clock, and the output is the horizontal distance to the right of the vertical diameter in radius lengths. This is our other super important function. I'll just call it h this time. And many of you know what that is. Cosine. Okay? How do you understand well what cosine is? How do you understand well what cosine is? What's it about? You know, without hesitation, you know what the input into cosine is, and you know what the output of cosine is. Those are the people who understand cosine. The input is our angle, swept counterclockwise from the 3 o'clock position. The output is the horizontal distance, and that's what we're showing here on the vertical axis, the horizontal distance to the right of the vertical diameter in radius lengths. Okay, so let's just estimate some cosines here. So right there for this angle, estimate the cosine. What would you estimate, and tell the person next to you, what would you estimate the cosine to be here for this angle, which is about 2 radians? About 2 radians. What would you estimate the cosine to be? Go. Okay, Daniel Wallace. Daniel, what would you estimate that cosine to be for that angle? 1/3. What's that? 1/3. What do you think? Agree with that? What's that? He wants -1/3. Does it matter? How do we define the output? As the horizontal distance to the right of the vertical diameter. That gives us positive. So what about -1/3? What do you think? All right, so this is about 2 radians, if you remember. This angle that I'm showing you, this is pretty close to 2 radians, about. So let's do cosine of 2. Put in cosine of 2. And we're thinking it's about -1/3 or -0.3. What do you get? -0.4. Okay, pretty close. Pretty close to -1/3. And what does that 0.4 represent? What does that 0.4 represent? What's it about? What's that? It's the fraction of a radius, right? It's about 40% of a radius, or a fraction of a radius, that we are, because it's negative, to the left. So we're about 0.4 of the way to a full radius. Any questions? All right, so back to this. So this is putting it together now. If I were to pause it, say right here. So here I'm showing what? This is the vertical distance. So which function is this? That's sine. This is the horizontal distance, so it's... Okay, now, in terms of locating the position of the bug, in terms of sine and cosine, well, you've already kind of known what those values are in terms of the coordinate plane. What are those? So this value right here, you've been dealing with it all your life. What is it? That value of sine in relation to the coordinate plane? What is it? What's that? It's the y coordinate, isn't it the y coordinate? And what's this right here? X coordinate. So by learning what sine and cosine are, we just really found the coordinates of this point. If we wrote that, the coordinates of that point as x, y. Okay, still got a minute, hold on. So how could we now write the coordinates of that point in terms of our sine and cosine? X is, or this, what is that? That's cosine. And this is sine. But we have to be very careful on what units is that giving us. Radius lengths. Radians are for angles openness. Radius lengths are for distance. So I want you to estimate the cosine and the sine right here. Last exercise. Estimate the cosine and the sine for what the angle I'm showing you right here. Estimate the cosine and sine. Go. So it's this angle right here. Estimate the sine and cosine of that angle. Okay, what do you think about the cosine? What's an estimate for the cosine? Grant, what do you think? Estimate the cosine. Not sure? Tanner, what do you estimate for the cosine? What's that? Uh-oh. So who's a... Cujo. Oh, come on. We just said, it's just 50 minutes of my life for nothing. Estimate the cosine. Let's see, Andrew. Okay, so who are the people that understand what cosine are? The people that understand the input and output. What's the output of cosine? Horizontal distance to the right of the vertical diameter measured in radius lengths. So what's the horizontal distance to the right measured in radius lengths? Negative 0.8 would be a good estimate for the cosine. All right, what about the sine? Negative. Oh no. Negative 0.6. Negative 0.6. Okay, I'm gonna in the next hour or so, I'll finalize your homework for Friday. Due in lecture.